Hey everyone, welcome back. Today we're going to be talking about stacks, and a stack is a last in, first out data structure, meaning the last thing you put onto the stack is the first thing you'll pull out when you need to retrieve something. And we're going to implement it in Java using both an array and a singly linked list to show you how that works in both cases. And we'll also use a stack to do a string reversal program where you provide a string and the stack is used to read out the string in the reverse order. So thanks for watching, and let's get started. Alright, so a stack has two fundamental operations, push and pop. You push items onto the stack, and you pop items off of the stack. And this illustration will show you what I mean. So let's say you have a stack, an empty stack, and you issue the command stack.push, and let's say it's a stack of characters, and you push the character A. This is what that looks like. If you then push B onto the stack, the B will go on top of the A, and then if you push C onto the stack, that will go on top of the B, and so on to D, to E, to F, to G, however many items you want to push onto the stack. And then you end up with a stack like this, A, B, C, D, E, F, G from bottom to top. If you want to pop something off the stack, then you just issue the pop command. You don't have to provide any arguments because pop automatically pulls the top item off of the stack, because as I said, this is a last in, first out data structure, so you don't have to tell it what to pop, it'll pop the top. So it'll pop G, and if you issue the next command, stack.pop, it'll pop F. If you do it again, it'll pop E, and so on. I think you get the idea. So why don't we try to implement this now using an algorithm. We'll write some algorithms here for pushing and popping, and once we're done with that, we'll implement in Java. And here's a list of functions we're going to implement for a stack. We're going to obviously push and pop. Notice that pop will return something, and push will take something as a parameter and push it onto the stack. And right now, you're used to seeing some data type like an int or a string, but I've just put T here. And T will represent what we'll call a generic type. And I'll talk more about that once we get into the Java code. And we're also going to implement size so we can figure out how big the stack is, check if it's empty, and also be able to see what's on top without taking it off. Pop will remove the top item from the stack. Pop will do that, but top will only tell you what's on the top. So let's see if we can write the algorithms for these functions, and from there we'll proceed to the Java code. And first we need to make a design choice, and I'm going to choose to signify the empty list by showing the top as being -1. And I'll show you why that is, but first let's do this. If the top was -1 and you want to know the size of the list when it's empty, you want the list to have size 0, so you return top +1, because if it's -1, then you add 1 to it, you're returning 0 for the size. If you want to know if it's empty, then what you'll do is return the value of top being less than 0. In other words, if that's the case, it'll return true. So if top is -1, it's empty. If top is not -1, then it's not empty. And then if you just want to know what the top is without returning it or getting rid of it, first you're going to check if it's empty. And if it is empty, then what we're going to do is throw an exception. We'll throw an empty stack exception. And if it's not empty, then you can return the stack's top value, the value at the top. Next, let's implement push. Let's say you want to push an element E onto the stack. Again, if the size equals, let's say, we'll call it stack max, because your stack will have a fixed size, and then let's say you have whatever it is, 5 elements, 500 elements, whatever, then if you try to push something onto a full stack, you should throw a full stack exception. If that's not the case, then you let top equal top +1. In other words, you increment the top and set the top element of the stack equal to the element that you're trying to push. So that's pretty straightforward. None of these are very difficult when it comes to stack operations. Pop, and this takes the top element off the stack and removes it. So if is empty, so you got to check for that because you can't pop off an empty stack. You should throw an empty stack exception. Then you have let's say a dummy element or a temporary element, set it equal to the top element of the stack. And then you take the stack, its top element, and you null that out. And then this time you're going to decrement the top. So top is equal to top minus 1. And then you just return E. So that's it. I mean, with these algorithms, the way we've written them, we should be able to translate them directly into the Java code. Let's do that now, and I'll walk you through it. All right, I've opened up IntelliJ IDEA, and this is where I'm going to edit my source files for this stack program in Java. I'm going to click New Project, and it's going to be a Java 17 program. Click Next, and then Next again. And I'm going to call this, this project Stack, and click Finish. And so now I have an empty project, and the first thing I'm going to do is create something called an interface. Now an interface is similar to what you might see in C++ with a header file, where you've defined some functions that you're going to implement later. But here in the source file, or the source folder, I'm going to click New Java Class. And then here, instead of class, I'm going to click Interface. And so I'm going to go here and click Name, and I'm going to call this stack with a capital S. Now what I can do here is introduce something else. There's two things I'm introducing here. First, the interface, and an interface is kind of like a contract. So if you build a class that implements this interface stack, then that class is not complete until it has defined functionality for every function identified in this interface. So it's kind of like a contract. But that's the first concept I want to introduce here. The other one is something called generics. Wouldn't it be nice, for example, if every time you had to build a stack with a different data type, you didn't have to go and define a whole new stack? So, for example, if I have an array of integers, that array can only hold integers. If you want another structure, or if you want that array to hold strings or characters or some other object, then you're out of luck. You have to build a whole new array for that. But with generics, you can say you have some sort of generic data structure that holds items of any object type. And then you define the object type when you create something using that methodology. The way you define a generic is you just use angle brackets after the name of the interface. And the same works with classes. You can just use angle brackets. And inside, you can use a letter, a word, some keyword to identify the type. I'm just going to use capital T to signify some type. This stack will consist of some data type T. And then I'm going to define the function, or I'm going to declare the functions here that any class that implements this interface must define. So I'm going to say void push. And because we're doing generics, it's not going to say, for example, string element. For example, you can, instead of string, constraining this stack to a string, you can just say T. It's whatever data type that this stack consists of. Then I have pop, which will return an item of type T, whatever T ends up being. And I guess I should have said I'm going to describe 3 new concepts. The last one is throwing exceptions. So in Java, you would say throws, and then some exception, and I'm going to define one, and I'm going to call it, let's call it empty stack exception. All right, so this thing is going to throw an empty stack exception, and what that means is if you try to pop, what errors could you have if you try to pop something off of a stack? Well, one thing I can think of is if the stack is empty, there's nothing to pop. So you should get an error, and it should throw something, and I'm going to call it empty stack exception. And now that I think about it, I want push to also throw an exception, except I want this to throw full stack exception. Because, and we're going to have to define this, and that's why it's red. We're going to have to define something called full stack exception. There already is something in the util class called empty stack exception, but I'm going to define my own empty stack exception. But there's no full stack exception in the Java language, so I'm going to create one. So because a stack will have a defined size, and if you try to put something on top of that defined size, you'll be overflowing, and so it should give you an error. I want to be able to find the size of a stack, and I want to know if it's empty or not. And finally, I want to be able to know what's on top. What is that top element without actually returning it? Throws another empty stack exception because you can't find the top of an empty stack. There's nothing there. And so what we're going to end up doing, and I'm going to delete this. We don't want the java.util empty stack. We're going to define our own empty stack exception. Okay, so what we're going to do here is implement this interface on a class, and when that happens, that class will not be complete until every one of these functions is defined inside that class. First, let's define the exceptions. I'm going to go into my source, and I'm going to click New Java Class, and this time it is a class, not an interface. And I'm going to call this class Empty Stack Exception. And what I'm going to do here is that I'm going to extend another class. Now I'm making a subclass of some other exception. The type of exception this is a runtime exception. And the reason is, it only occurs when at runtime you try to push something else onto a stack after the stack is already, or I'm sorry, you try to pop something off of a stack or find the top of a stack that's already empty. And so what you want to do is extend runtime, extends runtime exception. So empty stack exception is now a subclass of runtime exception. And the reason you want this is because if you just rely on Java to create the runtime exception, it's not going to give you a very good answer as to why you got an error. This way you can control what the error message is. During debugging, you'll see in your console that you have an error, and you control what that error says. You can actually write, your stack is empty. That may make more sense to the user or the programmer. So I'm going to say public empty stack exception, and it's going to take an error message as its input. And then we're just going to call the super constructor and pass along that error so that the runtime exception can be declared with the correct message. Go into source, click New Java Class, and call it full stack exception. Here I need to write extends runtime exception. And we're good. So we have a full stack exception defined, and we have an empty stack exception defined. So now we can start writing the meat of this program, and I'm going to define a class called ArrayStack, because later I'm going to create a class called ListStack. And the reason is, we talked about this earlier, that we're going to implement a stack using two different underlying data structures. First, we're going to use an array to create a stack, and then we're going to use a singly linked list to create a stack. And this is important because we talked about both arrays and singly linked lists before as their own data structures. But when you implement a stack, you need something to implement it with, some underlying data structure. So I'm going to go into my source, and I'm going to create a new Java class, and we're going to call this ArrayStack. Now this is going to also take generics, because I want to be able to create a stack using an array that has an underlying data type of any type that you give it, so making it generic and more flexible. And then I'm going to say this implements, and that's the keyword you use to implement an interface, and it's going to implement the interface we created before, stack T. Now you'll notice that immediately you get an error, And the reason is we haven't actually defined all of the functions we declared in the stack interface. Have some protected items here. I'm going to call it int capacity. And so like if you want to give an array stack some capacity, this variable will hold it. And then I'm going to create a constant, public static final int capacity, and set that equal to 500. So if you create an array stack without any arguments for size, it will automatically assume its capacity is 500, for example. And later we'll change this to a smaller number just to test whether or not it catches the full stack exception. If you like have a stack of size 5 and you try to add a 6th item, we'll change it later to make sure that that works. And then protected t, this is going to be the array. So don't be fooled by t. It's basically the data type that this is going to be based on. You can think of it like this. It's basically like a string stack, if that makes better sense, because you're used to seeing a data type there. But instead of string, we're going to put t. In other words, whatever data type it gets, that's the array type it will create. And then finally, I'm going to use this convention where the top of the array is going to be an integer identified by the number -1. Top equals -1. Then the default constructor, public array stack, it's going to be whatever the other constructor is for this at capacity, the constant. So the generic stack will have capacity 500. And if you'll notice, I use the this keyword, which means I need another constructor that takes integer as an input. So I'm going to say public array stack. And that's going to take an integer capacity of some kind. And that gets rid of the error. And I'm going to say capacity is equal to the cap given. And then the stack is going to be a new object with that capacity of that size. Now you get an error because it says required an array of type t, but I provided an array of type object. And so I'm going to cast it to t. I can click this helpful hint here, IntelliJ IDEA, and it'll do the casting for me. But just to show you, you can the way you cast is you put parentheses with the type before it, and that will get rid of the error. Now it sort of light highlights it, but that's because it's giving you a warning. Unchecked cast, object to type T. Ignore the error. I won't often say that, or I'm sorry, this is not an error, this is a warning. Ignore the warning. Basically, this is saying you didn't check to make sure the object given is going to be of type T. Well, T is generic, so there's no way of knowing what type it will be. So perhaps in a later version of Java, they'll clean this up and not make that a warning. If you're using generics, I'm not sure, but at this point, just ignore the warning. It'll be fine. It should still work. Some of these will be pretty fast. The size will just return whatever the top is plus 1. And then public boolean is empty. That should just return whether or not the top is less than 0. So if the top is -1, it should return true. So it's going to check and return true if that's the case. Then public void push t element. And remember, this is going to throw a full stack exception. It will throw it if you try to push onto a full stack. So if the size is equal to capacity, then you're going to throw new full stack exception with the message stack is full. I'm going to set the stack top equal to element. Now I've got this funny prefix increment operator, plus top. And what this is going to do is going to increment the top first to the item you just pushed onto the stack. So if the stack points to number 4, it's not going to point to number 5. And then it's going to add the element to the stack at that index. So that's very important. So you don't want to do this, where you have top plus plus, because then it's going to add the element to the index below the top, and then increment the pointer to top. So that's why I have the prefix increment operator. Top. T pop throws empty stack exception. And then if is empty, then throw new empty stack exception. Otherwise, you're going to say T element is equal to stack top, the top item on the stack. Then stack top minus minus, and now we use postfix because we don't want to decrement till we're done, equals null. So you're going to make the top null and then decrement the top pointer to the next one down, and then return element. All right. So this should follow exactly along with the algorithms we wrote. And then next, I want to implement top. This tells you what's on top without actually removing it. And this is also going to throw an empty stack exception. And then if is empty, throw new empty stack exception. Otherwise, just return the stack top element. Or now I'm going to implement the toString method, and I'm going to override the general functionality of it. So I'm going to say at override, and that's optional. You don't really need to write that directive. I tend to do it as a habit to show that this is overriding a standard functionality. So I'm going to say public string toString. This makes it so that when you do a system out print line on the stack itself, it'll print it in a certain format in a given way. I'm going to say string builder s, and then s is equal to new string builder, and we'll say bracket, and then if the size is greater than 0, then s.append the top element. Then if size is greater than 1, so it's always going to do, if it's greater than 0, it's always going to do that first step. And then if size is greater than 1, for I equals 1, I less than size, I plus plus, what you're going to do there is s.append a comma, and then append the stack's ith element. So this will format it so you're just putting commas in between each element as you print it out, or as you add it to the string builder. And then if the size equals 0, s.append just an empty bracket, right bracket, else s.append top. And what I'm doing here is to show that the top element is the one at the end, not the first element. So I think I misspoke here. So if the size is greater than 0, implement the element that you first added into the stack, in other words, the bottom of the stack. Remember, the last thing you added is the top. So in the end here, if you have a size 0 stack, we don't want to do all this. If size is greater than 1, if it's greater than 0, it'll go right here and just close out the bracket. It'll show an empty bracket, nothing inside the brackets if you have size 0. Otherwise, you're going to append :top to show that the last element there is the top in this stack using an array. And then so in the end, once you're done doing all the appending, you can just return s.toString. And that's how you use a string builder. And you might wonder why not just concatenate this string with s plus equals and so on. You can do that. It's just faster in Java to use, faster in terms of execution for Java to use a string builder. And so I've used string builder instead. But you're more than welcome to do the s plus equals. It likely won't make that much of a difference in this application. Okay, so we've implemented the array stack class, and now we need to somehow create a main class to run this. So I'm going to go back into stack, source, the source folder. I'm going to right-click Java class and call this stack app. Click enter. And we have an empty stack app, and here I'm going to say public static void main string arg, so it has a main method. And I'm just going to call this, I'm going to create some boundary here so we know which part we're going to do first. This is the stack implemented, let's say, using an array. Later we're going to do the same thing with the list, singly linked list. So array stack, we need to create an actual implementation of this. And here, let's say we create a character array. Array stack with the character data type. So I'm going to say array stack as is equal to a new array stack. And that's the syntax. And I'm going to say system dot, and now as you see here, I've created an array stack with no arguments, which means this should create an array stack with 500 elements. That's the default capacity. But if I put a number in here, like say 300, it should create an array stack of a different capacity. All right, so first thing I want to do is system.out.println as. And this should use the overridden toString method to print the stack as it is now. And we can actually go ahead and run this program now to make sure it prints out what we want. And there we have it. So we see an empty stack down here with empty brackets. So there's nothing in it. Great. I'm going to now push some items onto the stack. I'm going to say as.push the character A. And notice I'm using single quotes because this is a character. Oops, I forgot to tell it to print again. So I'm just going to copy the print statement and put it here. And there it is. The stack with letter A and the word top kind of showing you that A is the top. Great. So what happens now if we add more elements to it? as.push, let's say B, and I'm going to copy this down a few times. I'm going to push C, push D, and push E. And so the last thing should be the top, E. I'm going to run this again. Oh, I have to actually print again. Great. So we added A, it was the top. We have an empty list that shows A, B, C, D, E, then E is the top. So everything appears to be working. Let's try popping things off the top, off the stack. And so I can say as.pop, and then I can write system. I can then print out what we have. So this should pop E off, and I should just see A through D, and D is the new top, if I've done this correctly. And it works. We popped E off, we popped the top, and now D is the new top, and we see A, B, C, D. What else can we do? We can print out the top element without popping it. System.out.println, and I'm going to say as.top. And this will just print the top without removing it. And you can see that it's not removed because I'll print the stack again and show that D is still on top. It'll print D and show D still on top. So there you have it. We printed the top, and then it shows D still on top. So great, everything is working with this array-based stack. We've implemented push and pop and some other functionality here, and we can move on now to try to implement this in a linked list. All right, so now I'm going to go back into the source. I'm going to create a new class, and this will be the list-based stack. So we're going to do Java class list stack, and it's going to be based on a singly linked list. And here we go. This is also going to be based on generics. I'm going to say list stack T. All right, so well, this is going to use nodes like we did with the with when we actually built the singly linked list a couple of videos back, and also the doubly linked list in the last video. So why don't we go ahead and define a specialized node class for this, because we're using generics now. So I'm going to leave this aside and we'll come back to it because we're going to need nodes for it, as I just recalled. So let's go back to, let's go in here and click source, new Java class, and we'll call it node. All right, and this is also going to take generic elements. A node can carry any type of data, and it's going to have some constant data type element. And then I'm going to say a pointer, we'll call it a reference to the next node. And then public node, it's going to take some type and some reference to the next node. It looks like I've already used that, so let's just call this next. And it'll take next node as an input in the constructor. And then whatever the T provided will be the element of that type. In fact, we might want to call this element so it's more understandable what's going on there. And then we'll let next equal next node. Now we need a way to get the element associated with the node and also to get its next node. Because they're private fields, we have getter methods. So it's going to return, to get an element, you're going to return its type T, and we're going to call it getElement, and that will simply return element. And then if you want to return the next node, it's going to return a node of type T when you get next, and that should just return next. Notice I used final here to indicate the element and then the next node. The reason is, once I create a node, I'm not going to override that node. So for example, if I create a node A, or I create a node with element string, and it has the value A and it has a pointer to another node, I'm not going to set the element later. I'm not going to set its next node. In other words, you create a node, you add it to the stack. And if you want to remove the node, you pop it off the stack and you add a new node. You don't modify the node that's already there. That's why these are final fields. Okay, back in the list stack, I'm going to create a protected node with the type T, and we'll call it top. This will be the top of the stack. And then protected int size to hold the size of the stack. And then what we'll want to do is initialize this using a constructor. I'm going to say public list stack and set the size to 0. It's a little bit different than using an array stack, which uses array indexes. So that's why you let top equal -1. Here you just let top equal null if it's empty. And then what we want to do is start implementing the functions in the stack interface. So we have size, that's the easiest one, and I'm just going to return size. Then boolean is empty. In this case, we're just going to return top equals null. So if top is null, it will return true. In other words, an empty list. And then push, public void push element of type T onto the stack. And so in this case, you'll just set the top equal to a new node object with the element and referencing top. And of course, you'll need to increase the size of the stack once you push something onto it. Great. So now what we want is to be able to pop an element of type T, throws empty stack exception. And notice I didn't, when we did the array stack and we did the push operation, we had it throw a full stack exception. But in this case, I'm not going to run up against a full stack issue. I've basically created an infinitely large stack. I could put a capacity on it, but the reason I had to put a capacity on the array one is because you can't have an infinite array. An array has a size when you initialize it. Not so with a linked list. With a linked list, you can make it as long as you like, so long as there's memory on your computer available. So I'm going to leave it this way, although you could certainly identify a stack maximum and limit it to that if you really wanted. All right, so moving on. If is empty, throw new empty stack exception. If that's not the case, popped node of type T is going to equal top.getElement. And then we're going to set top equal to top.getNext and decrease the size of the stack by 1. And then you'll just return the popped node. Next, if you just want to look at the top, what value that is, it's gonna be able to throw an empty stack exception as well. Then if is empty, throw new empty stack exception. And if that's not the case, return the top.getElement. And again, we want to be able to print string to string. And I'm going to use a string builder, and we'll call it s equals, and this is going to be a ternary operator. So the string builder s is going to be, if it's already an empty stack, then just new string builder starting with an empty bracket. Otherwise, new string builder starting with top to signify that the first element is the top of the stack. Then node of type T, current, set it equal to top. If the size is greater than 0, then s.append the top. If size is further greater than 1, then for, let's say, I equals 1 to I less than size, I plus plus, what you're going to do is current equals current.getNext, s.append an arrow, s.append current.getElement. And when that's done, you're just going to return s, whatever it is, plus the ending bracket. Let's go to the stack app and start creating a stack out of the list instead of the array. So how do we do that? First, we're going to have to create an instance of the list, so list stack. And let's say it's of type integer. So of type integer, ls is equal to new list stack. All right? And then system.out.println ls. Let's see if it prints out what we want, which is the empty list. And after we do that, we're going to say ls.push 1 onto the stack, and then again print out the ls, the links. Then let's say we just want to print out the size of the stack, ls.size, and then ls.push 3, and then let's push a few other things, and then again we'll print out the stack size. We'll check whether it's empty, and then maybe we'll pop some items. So we'll say ls.pop, and then print the stack again. And let's see what we get here. I'm going to comment out the previous array stack so we can just focus on the link stack. There we have it. First we created an empty stack, and it shows us exactly that, an empty stack. Then we have a stack with just the 1 on it, and so it shows the top is 1. And then I think after that what we had was print the size, which was 1. And then we ended up pushing 3, 4, and 5 onto the stack. So now 5 is the top. And it shows you that here, 5, 4, 3, 1. And then that shows a size of 4, because we printed the size again. Is empty is false. And then we popped 5 off of the stack. And so we'll end up with just 4, 3, 1, and 4 as the top. Everything appears to be working smoothly. And so what we've done is we've implemented the stack in both using an array and using a list. And just to show you how versatile generics are, if I wanted to create the same list-based stack using characters, I would have, without using generics, I would have to create a whole new list stack, class that will take characters or some other type of data separately. But now, if I wanted to, I could just take this and type character, and then here I can just put characters. And then if I print this, it should just print those characters because it's generic. It doesn't care about the type. And there we have it. We have given it a different data type, and it didn't care because we're using generics. And that's really the power there with generics. You don't have to keep rewriting classes for every single data type you want to use. A couple things I want to cover before we move on and finish. And I'm going to comment out the list stack because it'll work the same in this instance as well. But I'm going to focus on the array stack for now. Now, we didn't actually test the exceptions, so let's test that now. What if I go to the array stack definition and I make the capacity 5? Okay, so now the array stack only has a capacity of 5. So if I go in here and I've added 1, 2, 3, 4, 5 items to the stack, everything should work still. So when I run this program, everything works great for the array stack. But what happens if I add another item? Let's go here and say as.push, and let's push F onto it. I should get a full stack exception with the message that we gave it, which is stack is full. So I go to run stack app, and there we have it. It prints out the first few outputs before it runs into an error. Exception in thread main, full stack exception, stack is full. So that works out perfectly. So our error handling is working as we intended it to. And let's say we try to pop something off of an empty stack. So I'm going to get rid of that, and let's say I just have the following instructions. I create a new stack, and I try to pop something off of the stack. And I get another error in thread main. Empty stack exception, stack is empty. And the same thing would happen if I would check for top in that case. All right, one last thing I want to try before we finish this video is apply the stack to do something. For example, reversing a string. If you add each character of a string to a stack, when you pop those off, they'll come off in reverse order because of the LIFO structure, last in, first out nature of a stack. So I'm going to create another class, and this one is going to be called, let's call it string reverser. Okay, and what we're going to do here is have it hold a protected string called string. And then its constructor will simply, actually let's give it a parameter, string input string, and it'll assign input string to string. Very simple constructor. And then public string, reverse string, will then reverse any input it's given once we create the object and we call this on it. Okay, so here, let's just do it with the array stack. The implementation using the list would be very similar. But if I use an array stack of characters and call it stack equals new array stack, and it's the default, I should go back and change that to 500. No, remember I changed the capacity, the default capacity, to 5 to test the full stack exception. I'm going to change that back to 500. And I'll go back to string reverser. Okay, so now I have an empty stack of size 500 to begin with, or capacity 500. And then I'm going to let length equal the string's length. And then let's string builder. Let's call it SB equals new string builder. Then for int I equals 0, I less than the length, I plus plus, stack.push, and what we want to push is string.character at I. And then for j equals 0, j less than length, j plus plus, I want to sb.append stack.pop. And you could actually use top if you wanted to maintain the stack. But I don't really need to maintain the stack for any reason in this case. Because we're just using the stack to reverse the string and then we'll be done. And in the end, you just want to return sb.toString. So that should reverse a string for us, and now we can test this out in the stack app. And here we can start applying the the string reverser class. Here, let's do it before the singly linked list. And let's say string reverser sr is equal to new string reverser, and we'll give it a string. The string reverse is given. And I just want to say system.out.println sr.reverse string. There we go. And so now I should be able to reverse the string using this method. And let's see how it works. If I go to run, so there we have it. I didn't comment anything else, so it's running through the whole program. It's doing the array stack operations. And then right here in the middle, it's printed the string reverse in reverse. So it works. We've applied the stack to do something, and in this case, reverse a string. So congratulations, well done. This is a huge accomplishment. We went through a lot of things in this video. We'll cover them all in our review. So let's go back and do that and see where we go from here. All right, very well done. We finished the stack application. We've implemented a stack in both a list, using a singly linked list, and an array. And we were able to implement the stack to use, to reverse a string. So we actually applied it to do something. That's certainly not the most important application, but it was easy to get our arms around for this simple example. And, we went through a few different concepts here that we hadn't covered before or didn't cover as much previously. One of them was creating exception classes. We did the empty stack exception and the full stack exception as extensions of the runtime exception, and we showed how that works. And we allowed certain functions to throw those exceptions. For example, trying to push onto a full stack, a stack that has a top capacity, can yield a full stack exception. Or trying to pop or find the top of a stack that's empty will yield an empty stack exception. Both things we were able to use in this application. We also looked at generics, something we hadn't really touched on before, and I showed you how you can use generics to make a class more flexible so that the class isn't bound to a particular data type, and that's really handy. And in broad terms, what we've done here is we've implemented one data structure using another. So we implemented the stack using an array, but we also implemented the stack using a singly linked list. That just goes to show that some structures may be more fundamental than others. A stack is a concept that can be implemented using an array or a list, but by itself, it makes no sense. I mean, a stack of what? How are you traversing it? How are you adding things on it and removing it? Well, you need some underlying structure for that, and that's where the array and the singly linked list come in. In a way, you can think of a stack as sort of a second-order data structure, if you'd like. In the next video, what we're going to do is cover queues. A queue is a first-in, first-out data structure, where the first thing that you've added to it is the first thing removed. You can think of it as sort of a queue at a bank. If you're waiting as a customer, the first person in the line is the first person to be served. And so I hope you join me there in the next video. It's sort of going to continue our progress here on fundamental data structures that you should be familiar with. Thanks for watching, and I'll see you then.